AI made it in 10 minutes. This will not work as you think. That's like using an expensive 3D scanner. This is an owl, a benchmark object for testing 3D scanners. And this is a replica made not with a scanner, not even with photogrammetry, but with a simple image to 3D AI. And it all started with a question. How accurate are 3D modeling AIs? Yes, we know you can turn fictional images into 3D models, but what about existing structures? What about mechanical parts? Is it consistent and accurate enough to replace expensive 3D scanners? I'm Kacpi, and today I will test the limits of image to 3D model technology. I will also teach you how to replicate almost anything without any hardware, software knowledge, or even experience. Let's begin with the image to 3D AI concept, which, as you already know, turns photos into 3D printable models. Even better than that are advanced tools that use multiple images from different perspectives to make highly detailed models. But are they accurate? To test this, I'm going to grab a few real objects, take quick photos with my phone from 4 perspectives, then run them through AI to make 3D models. Next, I will 3D print them and compare them with the originals. A simple but effective way of testing accuracy of AI models. As for the tool, we're going to use Highten 3D, since they wrote me a very nice email about releasing a new improved version 2.0. They claim it's their most advanced tool yet, so it's a great opportunity to put it to the test. On the first round, we have a benchmark owl. It has quite a lot of details like feathers and crevices, and the geometry is not quite obvious. The AI took about 15 minutes to generate the geometry and texture, and honestly, it was a lot better than I expected. There were only a few tiny errors, but overall, the results were incredibly accurate. I mean, just compare it with this model, which is a 3D scan made with a $600 device. That's really tough competition, while AI required significantly less input. It's also fair to mention that I had to manually scale the AI model, because it obviously can't really tell the dimensions from just a picture. Okay, now let's raise the bar a little. This time I'm trying a T-candle house, because on top of having quite a complicated geometry and details, it is also hollow inside with many openings. Again, I took 4 pictures, ran it through Highten and printed it. Now, what we can learn here is that the AI catches all the tiny details, like roof tiles or windows. It also didn't lose track of which wall is which, and the roof geometry is clearly very accurate. The openings, however, have been plugged, as the AI could not tell that those are see-through holes. And yet, the biggest opening at the bottom was somehow well interpreted, despite only being visible from just one angle. The whole structure is not hollow like the original item, but the T-candle opening is quite accurate. The lesson here is that the AI is only as good as the input we provide. And since hollow or empty parts are not easily captured in external perspective photographs, the accuracy is limited to the outside surfaces. But if you manage to capture interiors well enough, like I accidentally did here, there is a chance to partially include the interiors as well. And now for the final boss of this test, hard surface objects. In my experience, this is the most tricky part for 3D scanners, photogrammetry and AI, because with organic shapes, all those nuances and details act as an anchor points for the software. But a plain surface has none of that, and it's way easier to lose track of the geometry. To test how AI handles that, we need to accurately measure tiny differences. And so I designed a funky little cog in Blender and made a perfect case for it. Then generated a model of just the inside thingy, printed it, and tried to fit it into the case. If it fits, we know it's accurate enough. And to make it even harder, I not only included multiple shapes on this side, but also made the whole top surface tilted a little bit. Only the correct slope angle will actually fit the mold. Now honestly, I thought I overstepped a little, because in the pictures I took, I could barely tell that the sides were not parallel. And even the slightest miscalculation, like bigger teeth or smaller shaft radius, would make the part not fit the case anymore. And so, after printing it, here comes the moment of truth. And it fits. Barely, because there was some friction on the top and the bottom, but it was good enough to fit the mold. The clearance between the original cog and the case was about 0.5 millimeter, so any shape deformations were below that value. Now, does it mean Image to 3D AI is perfect for hard surface tools? Probably not. The final model was way too organic in shape, but that was not really a point of our little test. The goal was to test the accuracy, and that turned out a lot better than I expected. I think if we give it a few more months, we're going to get really close to replacing scanners with just AI generators. At least for simple objects. And now, on a personal note, 95% of my regular viewers are not subscribed to my channel. If this is you, please consider leaving me a sub. It would really help me build this channel and make more videos. Anyway, let me know in the comments what other objects you would replicate after this video. And if you want to learn how to generate detailed 3D models from scratch, here is a step-by-step video. Cheers!